Assalamualaikum and hi, my name is Syafiqah Binti Nadila and I am presenter 1.
My name is Noor Batrishia and I am presenter number 2.
Hi, Assalamualaikum. My name is Ismul Mutaqalliman Ibrahim. I am presenter number 3.
Hi, my name is Noor Aliesha Nadila Binti Muhamad and I am presenter number 4.
Hi, my name is Syaziyah Athirah Binti Hamdan and I am presenter number 5. Next, I will pass it to presenter number 6.
Assalamualaikum, my name is Muhamad Izman and I am the presenter 6.
In this video, we will go through how to apply linear algebra in inventory calculations. First, allow me to explain what inventory is. Inventory is made up of materials and things that are usable yet idle. Inventory is defined as the total capital investment over all the material stock in the firm at any given time. Or, in terms of money, it is defined as the total capital investment over all the material stock in the company at any given time. Raw material inventory, in-process inventory, and finished goods inventory are all examples of inventory. In our case study, because there is still a lot of inventory available, business want to know how much it's worth it. Excessive inventory might stifle an organization's ability to succeed. As a result, better inventory management is required in order to determine the inventory's value and quantity. Thus, the inventory can be easily calculated with linear algebra, and matrix multiplication is one of its methods. The owner of any store can calculate their inventory using this method because matrices are excellent for storing numbers and variables. Therefore, by using this matrix multiplication method, each store can calculate their inventory easily, quickly, and accurately without any doubt on the result of the calculation. Next, I'll pass it to presenter 2.
The purpose of this report is to illustrate how linear algebra can be applied.
Methodology linear algebra defined. Matrix dimension and entries n, m time n. Matrix A is a rectangular array of real number with m row and n columns. We refer to m and n as the dimension of the matrix. The numbers that appear in the matrix are called its entry. We customarily use capital letters A and B for the name of the matrix. At the left side, you can see matrix A example. A is a 2 times 3 matrix because it has 2 rows and 3 columns. At the right side, you can see matrix B. B is a 3 times 2 matrix because it has 3 rows and 2 columns. Example of linear algebra applied in real life. Example of matrix. As an example, if you had shoe store and you wanted an easy way to store their size small, medium and large, you could store this information in a matrix. The actual matrix is inside and includes the bracket. At this example, you can see that we use 3 times 3 matrix because it has 3 rows and 3 columns. A matrix is sort of like a box of information where you are keeping track of things both right and left. That's we call it columns, and up and down we call it as a row. Usually, a matrix contains a numbers or algebraic expression. You may have heard matrix called array, especially in computer science. Matrices are called multidimensional since we have data being stored in different directions in grid. The dimension of this matrix are 3 times 3 or 3 by 3. Since we have 3 rows and 3 columns, you always go down first and then over to get the dimension of the matrix. Matrices are great for storing numbers and variables. They are also great for solving systems of equations, which we will see later. Each number or variable inside the matrix is called an entry or element and can be identified by subscripts. That's all from me. Thank you.
The technique for matrix multiplication is the same as we have always done. In other words, in order to find the entry in position ij in the product matrix first and second, all you have to do is multiply the ith row of first matrix by the jth column of second matrix. Second matrix here is actually, you can think of it as a column vector because it only has the one column, so that's going to make it even easier. So let's have a look at the solutions. First of all, let's write out the matrix multiplication that the question gives. So what we are going to be doing is we are going to multiply the first matrix by second matrix, which is, you can think of it as a column vector. So our key step here is to perform the multiplication. What we are going to do to find the entry in position 1 1 is we are going to multiply the first row of first matrix by the first column of second matrix. And in fact that it only has one column, so we are always going to be using that column. Anyway, for next step, for entry 1 1, we have got 20 times 20 plus 28 times 25 plus 30 times 30. Next, for entry 2 1, we work with the second row of first matrix, and again the first column of second matrix, and again there's only one column in second matrix. So what we have got is 25 times 20 plus 35 times 25 plus 35 times 30. Finally, for entry 3 1, we work with the last row, so that the third row of first matrix and again the first column of second matrix, and what we have is 30 times 20 plus 42 times 25 plus 40 times 30. So here we have our 3 by 1 resulting matrix, and all we have to do is now the arithmetic to simplify what we have in each entry. So entry 1 1, we have got 2000. In entry 2 1, we got 2425, and finally in entry 3 1, we got 2850. So we are done here. We end up with our 3 by 1 matrix, and again the rule we follow is the same rule we always follow. Multiply the ith row of first matrix times the jth column of second matrix in order to figure out entry ij in the product matrix first and second.
Furthermore, I would like to explain about the discussion part. First, we must know what is the problem. The major problem is the 3 stars, which are Shu, Hippos and Kutsu, want to know their inventories work for all the shoes they have. They have 3 sizes of shoe, which are small, medium and large. Next, for the solution, we use matrix multiplication to solve the problem. The solution includes the size, which are small, medium and large, with the price of the shoes for the 3 star, Shu, Hippos and Kutsu. As we can see from table 1 is all the stock for size small, medium and large for the 3 stars, Shu, Hippos and Kutsu. Meanwhile, for table 2 it shows the price for the shoes in the 3 stars. From table 1 also we can see that it is 3 by 3 matrix, and from table 2 it is 3 by 1 matrix. One of the requirements in matrix multiplication is that the dimensions are computable when multiplying two matrices. It means that the number of columns in the first matrix and the number of rows in the second matrix is the same. The problem can be solved by multiplying the 3 by 3 matrix with the 3 by 1 matrix. It is because the number of columns in the first matrix is 3 and the number of rows in the second matrix is 3, which is the same. The final answer will get a 3 by 1 matrix. As shown in the result, the final total is Rm 7275. A small size of shoes will get a total of Rm 2000. Rm 2425 work for medium shoes, and a large size of shoes will get Rm 2850. Lastly, the problem can be solved by using matrix multiplications. Each of the stars get to know their inventories work for all the shoes they have. In matrix multiplication, it has theorems that must be followed, so when doing the solution we must be careful with all the theorems. Next part is about the conclusion, and I will pass it to Hilmi. That's all for me, thank you.
This is the conclusion of this case study video. In a nutshell, this case study comprises thorough information based on the study research by each member of this group. which is the purpose of the study, methodology, and results and discussion. We can observe how matrix theory can be utilized in regular human life in this assignment. There is a theory in this case study that can be used in the past and present and trying to solve these problems for the benefit of mankind in this ultra-modern world. To summarize, in this study, we solved one problem and successfully attempted to solve it using a matrix multiplication. The issues that have arisen may be resolved, and positive outcomes can be obtained. That's all from me. Thank you.